Hi everyone, welcome back. Lastly we talked about this ORB feature detection type, and also we compared ORB with the other feature detection types we already learned. And in this video we are gonna focus to the parameters, the member functions of this class. And we can switch to the code bar directly, and here this was the code from the previous video. I just added the some member functions which are important. So we are gonna focus these 5 member functions, these 5 parameters. Okay. So with the default parameter, it was working like this one. Here's some detection type. Maybe you can see now there are some yellow circles that on the detected corners, and here now we can play with the parameters and how they are affecting. For example, now there is for our case at least these are some noise, so we need to remove them. Okay. And let's start with the get edge threshold. What actually this is, for example, you can understand from the name, this is edge threshold, which is about the edges of the image, your target image. So currently, as soon as you increase this one, it's now 31, the value is 31. If you increase that, it's gonna ignore more the edge part of the your target image. So for example, in our case, the closest part to the edges, for example, maybe here and this star above, so these are very close to the edge, at least the closest one in our case. Now if we increase that, let's say orb, maybe we can just set it as maybe set edge threshold, let's make it 99 for example, which is 3 times higher than the default one. Now the expectation is so previously detected edges detected key points were 378, now it's 236, so it decreased, which is expected. Also now we can see here the star above is gone, also this closest part which is in below, they are also gone. So if you really increase this, for example, let's say if 200, I don't know, this is the meaning is pixel, for example, you can see the pixel value in here. So this star 52 is far to the edge, so maybe this is related to the pixel wise, so let's make it 55. So I just want to learn with you also. Maybe this is just representing the, yeah, maybe. So this is this circle, let's say 58. So if we make it 59, then it's also gonna gone. So this is totally meaning pixel. That's great. So let's say these circles are in the x value we're checking here, so they are 176 far. So if we make it 200, expectation that rectangle left side also gone. So that's meaning the pixel. So this is the pixel value we can understand now. So how much you want to ignore the edge side, so you can update this accordingly. So we can switch to the get fast threshold. This is the parameter. This is the parameter affecting our threshold accuracy. So currently is 20, and let's see how it looks like with the 20. So at the beginning we see actually this one. So now we want to remove these things. Currently is 20. Let's make it 50 and see how it's affecting. Now by making it, by making it 50, the number of the detected points, which is currently the 378, so it's gonna decrease the expectation. Also you see now all the noises in here at least is gone. So if you increase more, it's gonna also some duplicate circles here, maybe they are also gonna gone. So let's make 100. Oh, not decreased much, maybe make 200. Okay, 110 is good. So now really strong points is detecting according to the orb. Yeah, but now we also lost some points. So yeah, it's not we also need the combination of the other parameters to detect all. Get maximum features, this is easy to learn. The currently the value is 500, so if the detected points, the your target points are more than 500, it's not gonna be detected. So in our case, in the default parameters, it was giving the 378. So if you just limit it with just set maximum features as 50, this is gonna make you efficiency. This is gonna give you efficiency. You see, this now at least I can feel. Maybe from video you can also feel. So it's giving faster because it's only trying to detect 50. It's not trying to detect more, so it's more faster. It's more efficient, working efficiently. Okay, so this is the limitation. And number of levels, this is related to the iteration number. As soon as you as much as you increase this value, it's gonna detect more key points because it's gonna iterate more, so it's gonna try to detect more key points. So the defaultly number of levels is 8, which was giving in the default case, which was giving 378 key points. Now we can increase it to the double, which is 16. Now the expectation is gonna iterate more, the backend is gonna iterate more, so it's gonna give more key points, which is in here. Maybe in some cases the orb is not detecting your desired key points. Now in that case you can increase the number of levels, so it's gonna iterate more, but even it's giving some unexpected key points, but at least it's gonna also give you the desired which key points you want. Okay, and this score type, we can go to the definition. There are two score type in here, which is one is Harris score and fast score. I think there is here fast score is alternative value of the parameter that produces slightly less stable key points, but it is a little faster to compute. Yeah, the advantage between Harris score and the fast score, actually the orb is working little slower comparing to other feature detection types. You don't need to even measure the time. You can feel while running the code. For example, if I run with the default parameters, even if you see little, let's say 1 second a black screen, right? Because it's working slowly actually, because also it's using Harris score, which is very carefully trying to detect the key points. But if you make it fast, it's gonna be faster, but of course less accurate. Set score type, orb score, okay. Orb and score type, let's make it fast. The default you see 0, which is the enumeration is the Harris score. Now it's gonna work faster. Not really faster even, but yeah, by the way, it's giving the same number of the key points. Maybe it's luckily, yeah, because the expected this maybe should give less or non-accurate results compared with the Harris score. But anyway, yeah, the advantage, if your key points in your case are clear, I mean easy to detect, then in that case you can use fast score, so it's gonna detect faster. And since if the key points are clear, it's very easy to detect. No need to be very accurate one, which is the Harris score. Okay. For this video I'm done. Thanks for watching. See you in the next videos.